Here are your objectives for 2.4. Number 1, find slopes and equations of parallel and perpendicular lines. Number 2, interpret slope as a rate of change. And number 3, find a function's average rate of change. Okay, so let's talk about 3 really fast. Find a function's average rate of change. Find a function's slope. So if we take care of 1 and 2, 3 is kind of taking care of itself, hasn't it? Okay, but we'll talk about it in just a second. I want to make sure that our definitions are the same. Okay, so number 1, find slopes and equations of parallel and perpendicular lines. So first of all, if I say to you, the slope of a particular line is 1/2, tell me about the parallel line slope. Parallel lines have the same slope. Parallel lines are like this, so their slopes are going to be exactly the same. So if one line has a slope of 1/2, a line that's parallel to it will have a slope of 1/2. If one line has a slope of 2/3, negative 2/3, what's the equation, or what's the slope of a line that's parallel to it? Negative 2/3. Okay, so parallel lines have the same slope. Okay. What if I say the slope is 1/2? Give me the slope of a line that is perpendicular to it. That is. So the slope of a line that is perpendicular to this slope would be negative 2. If I said m equals 3/4, give me the slope of the line that's perpendicular to that. M would be negative 4/3, because perpendicular lines have opposite, reciprocal, reciprocal slopes. Okay? Everybody okay on that stuff? Okay, so if we are, the next thing says interpret slope as a rate of change. Okay, does every kind of function have a slope? What's up? They're crossing Miss Matos. Psst. Hey, grab him. Let's take that to him. Yeah. You're welcome. Does every function have a slope? What kind of function does not have a slope? That's fair. But what about like a parent function? So, in fact, a line is the only thing with a slope, right? But can you find a slope between 2 points on any function? Because we could like overlay a line on those two, right? So we can actually find slopes of things that are not lines because we're kind of overlaying a line there to figure out what's happening in that part of the function. Okay, so if I tell you f of x equals x squared, you know that's a parabola, thank you, and does not have a slope per se because it's a curve, right? But I could say between these 2 points, I need you to figure out the slope between these two sets of information. Okay, so for example, I'm going to tell you f of 0 is what? Actually, I don't have to tell you. You can tell me. Is 0, right? Because 0 squared is 0. Well, what about f of 1? 1, right? So x sub 1 would be 0, and x sub 2 would be 1 then, right? Okay, we could do it in this order, or you could start here with just only this, and you could figure this out, couldn't you? Okay, so what we're actually doing is we're actually using the slope formula, which we talked about in last section here, right? It's going to look a little different though because we're talking about a function, specifically a function. So really it's going to look something like this. Fx sub 2 minus fx sub 1 over x sub 2 minus x sub 1. Now, does that look exactly the same as this one right here? No, it doesn't, right? These have y's in it, these have function notation in it, but it doesn't stand for the same thing. The function at x sub 2 minus the function at x sub 1. So y sub 2 minus y sub 1, right? Over x sub 2 minus x sub 1. So do we know all these things already? If this is x sub 1 and this is x sub 2, then wouldn't this be the value of the function at x sub 2 and the value of the function at x sub 1? So plug in what we know. That's 1, right? We just figured it out. Minus 0 over 1 minus 0. So 1. What if I said, though, same equation, same parent function right here, but what if we used, instead of x sub 1 being 0 and x sub 2 being 1, what if we used x sub 1 was 1 and x sub 2 was 2? How would that change this? What is f of 1? Because 1 squared is 1, right? What is f of 2? 4, because 2 squared is 4. Okay? So if I use the same formula, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, plug in what you know. What's this one right here? That was 2, so that's this bottom one here, so that's a 4, minus 1 over x sub 2 is 2, x sub 1 is 1. So 4 minus 1 is 3, 2 minus 1 is 1, so that is 3. Okay, so curves, like a parabola, are not going to have a constant slope. It's more of a change along the path of the graph. Okay, so from 0 to 1, the slope, if I overlaid a straight line there, would be 1. From 1 to 2, if I overlaid a straight line there, that slope would be 3. Okay, so that's the kind of stuff that it's talking about here in section 2.4. Okay, so far? Any questions about this?